So in machine learning, generally you don't have to write any models because almost all the models are there in either scikit-learn or any other package that you use.
Hmm.
So yeah, generally, but the important thing that you need to do is, so what happens in machine learning is that so if I define the steps, it's basically you get the data, you
Mm-hmm.
you do feature engineering. Okay,
Okay.
feature
Okay.
engineering. Feature engineering means that you are creating the metrics
Hmm.
and then you plug in the metric that you have to your model, and then you do the prediction.
Okay.
So getting the data is generally not handled by us because it has to be handled by the business. So
Okay.
that will not be your work.
Hmm.
And the models are also generally pretty much defined. If you know which model to use, you are pretty much done.
Okay.
So it's basically the feature engineering that you have done, which is the most
Okay.
important part.
Hmm.
Okay, so you have probably opened your data set in the first NB, right? You can probably just make a clone of it.
Oh, this one?
Yeah, go a little bit down. Yeah, you have already pulled your data set and everything. So probably you can just make a copy out of it. So go to file. Yeah, make a copy. And probably you can delete the other cells, like the other cells that are not necessary in this. So yeah, you to delete a cell, you click on the cell. So like yes, then press escape and X. Press escape,
Oh, escape on X. Yeah. When it turns
escape,
blue.
and then X.
Okay.
Yeah. So similarly, the other cells that are, yeah, those logistic regression, those kinds of things, probably you can just delete them.
I can delete all these, right?
Yes.
Because they're already in the.
Yes, they're already in the first notebook. And probably the name also you can rename. Oh, you deleted all the cells?
Yeah, I happen to delete all the cells. I'll have to make another copy.
Oh, yeah, yeah. Uh, yeah, we just wanted to keep those where you data frames where you pull the data sets, na? That in 47, cell number 47, which is showing.
Okay, that one we'll leave that one.
Yes. And this one also, 64 also we can leave. Uh, so all these data related things you can, yeah, from here probably you can delete all the remaining ones.
Oh, iris we can do. Okay.
Probably import numpy as np. Okay, anyways, we can type them out again. Not an issue. Yes. Oh, did you delete? Okay, fine. So yeah, you can probably run them again. That will make it. And yes, of course, when you're printing a data frame, probably data frame dot head would make sense because if you print a data frame, all it means everything.
Yeah, I'm just testing here.
Yeah, you can do that in a new cell because the PD2 date time takes a lot of time, right? So if you
Yeah.
execute cell again, it will again take a lot of time to do
Okay.
everything. Yes, yes. So it's like once you execute a cell, the contents of the cell remain in memory, so you don't have to execute the same cell again and again.
Okay. So this is converting to week.
This should convert to week.
Yeah. Yeah. Yeah, this if I delete this, this is converting to. I mean, actually, not this one. Let me look at the first notebook. Yeah, this was able to get this into week.
Oh,
This
this
is
was, then you can probably take that one. Yeah.
yeah, 18th week and 2010.
Yeah. So then percentage U, percentage Y, you don't have, you need both, right? You need the year and the week as well.
Yeah, it's still going on. Why does this take so long? This function?
Because it's converting each element of a data frame, right? So those functions will
Hmm.
take a lot of time.
Oh, 420 functions are 420,000 rows are there. So,
Yes, so it's a lot of rows, so it will take a
hmm.
lot of time.
Okay.
So that is
So
why
all these
when
one,
yeah,
yeah. So this is there a way to know what are the see if we don't give any argument parameter name here,
yes.
where is this sending this to? Which what is the argument that it is taking?
So you can give those parameter names.
Yeah, but if we don't give it, is there something like a default where it goes if we don't give anything? Because in here we didn't give anything, right?
Yes. So how it works in Python is you can place like you can give parameter names as well as placeholder. So
Okay.
if you without parameter names, it comes in the how you can say in the uh, sequence in which you have defined the function.
Okay.
Okay,
Okay.
so
Okay.
it takes up in that way.
But not see there may be like 15 to 20 arguments that we can give, parameters that we can give here.
Yes,
If we did not see we for this we gave the name of the parameter, but for
yes,
this we didn't give anything.
because that is the first parameter.
The first parameter we don't have to give, we don't have to explicitly name it, huh?
No, it's not like that. It's like so. Whenever you do not give the parameter names, it takes them in order.
Hmm.
And if you
But
do not, if you give the name, then you can give any name. So let me give you an example.
okay,
Okay, you can stop sharing. I will share my one then.
okay,
Yeah,
okay,
just give me 2 minutes. Let me create my shell.
okay, okay.
Yeah, can you see the screen?
Yeah, I can see your screen.
So let me create a function. Okay, dummy. Let me create a function which has
Okay,
A, B, C, D parameters.
okay,
Okay, and let me say A equals to, so if I do something like this, these are like, so if I do not give these parameters, it will take these parameters by default.
Oh, in that. Okay.
Let me explain it to you.
Okay.
Okay, I could have just done this, done. Okay, let me give them one by one only, so it will be easier to understand. Okay, now
Okay.
I can now observe carefully. If I just run this, it takes like this.
Okay.
So what I have done is
If you
that
don't give any parameter.
I have not given anything, so it has taken the default one that I had shown.
Okay.
So it had taken the
Okay.
default. Okay. Now, in
Uh-huh.
in your current example, you are giving something like say ABC. Okay, let me give a string ABC and some other parameter. Okay, are you
Okay.
getting?
Yeah.
So the first parameter, I am not giving any parameter name.
A.
This one, this one.
Yeah.
So I'm not giving a parameter name before it.
Yeah. So it will be A.
Yes, and here I'm giving a parameter name.
Explicitly you're giving. Yeah.
Explicitly, I'm giving. So what
Okay.
will become is that the first one, the first parameter, since this is the first
Okay.
value that I'm passing and without any parameter name, the first parameter, which one was A, will become A.
Okay.
I did not pass B and C, so B and C are taken as default.
Ah. Okay. Okay.
But I have explicitly said that this is D assigned, this is D to D. So when print D became this is D.
Okay. So any unnamed parameters will be taken in the order where order which appears in the definition.
Yes, correct.
Okay.
Now,
If we give, mhm.
yes, now you cannot do something like this. You cannot do something like this. So you have to pass this one named parameter after unnamed parameter. You cannot do
Okay.
the opposite thing.
It has to be XYZ and A is equal to.
So what I have done is that I have first I have said that a equals to something, and then the second time I did not do anything. So Python cannot understand this kind of placement.
Hmm. Okay.
So your query is okay. Any questions on this?
No, that's fine. Yeah, got it.
Okay. Let me stop sharing. Yeah.
Want me to share?
Yeah. Okay. Now let's see your thing is done or not. Okay, it's
Yeah, it's
done. You
done.
can probably print. Okay.
Yeah.
Okay. Now one thing is that like to say is that you have changed your um, uh, that column and saved it in a new data frame.
Yeah.
But your original data frame is not changed. If you now check df underscore merged, don't execute that column. Uh,
Yeah.
Below at the like last column, type df dot underscore merged and dot head and see what it returns.
Which one? These ones?
No, no, the last cell. The last cell.
Here?
Yeah, below this cell. The last cell.
Yeah,
So
it would not have changed.
yeah, yeah. Can you go to the last cell? You don't need to execute this cell.
Okay.
Yes, this cell. No, X, where is, oh, okay, X, yes. So this is your X, right? But your X is not changed.
Yeah.
Yeah. So since we need to, so we are discussing on feature engineering, right? In feature engineering, because models do not understand strings and dates and those kinds of things, you have to change your date column into a number.
Yeah.
So how you can do that is that go to the next cell, do shift enter. Yeah, x within like a dictionary. Uh, this one date, yes, is equals to
H2.
what? Yeah, test two, whichever what you have created. Correct. Yes. Can you execute it? Shift enter and again see X.
Oh.
Shift enter and then do X head.
Okay. Okay.
Yeah, X dot head.
Print, right? Yeah. Or we can just give it.
Yeah, you were correct only. Yes. Yes. So you can see that the date is changed.
Yeah.
Similarly, you should change is holiday underscore X as well.
It's holiday underscore X. Okay.
Okay.
01, something like that.
Something like that. Now let me send you a nice function to change it.
Okay.
Okay. Let me give me 2 minutes. I'll send you a good way to change it.
Okay.
Yes. So I have sent on Hangouts. I've sent you a link. Can you open the link? So this is label encoder. Okay.
Hmm.
So what label encoder does is that it takes whatever values are there in your column or list or whatever and transforms it to unique values.
Okay.
So it's a very nice way. So whenever you know that your column has specific classes, classes, what I mean is that, for example, in your case, it's true, false.
Hmm.
Okay, or maybe it's something like man, woman, child, or something. You understand, right? It's like
Yeah.
some values are there which are repeating.
Okay.
Then you can use label encoder. Like in the second example, it's Paris, Tokyo, Amsterdam, something like that.
Yeah. Okay.
So it will transform that into unique numbers.
Okay. It'll take a series and then transform it into unique
And yes,
numbers.
so if you see the example here, let's see the Paris Tokyo example. So what they are doing is that L equals to pre-processing dot label encoder. It's creating a label encoder class.
Okay.
Then it's fitting le dot fit. So
Okay.
you have to pass the column. So like their column is Paris, Tokyo, Amsterdam.
Create a label
Okay.
encoder and then fit label encoder.
Yes,
Uh,
and then you can transform your. So once you fit it, you can transform it.
okay.
So that will give you the numbers.
Okay.
And then if you pass some numbers, it will inverse transform, like le dot inverse transform gives you the original classes.
Okay. So for each column we have to create one label encoder.
Correct.
Like LE1, LE2.
So for each, in your case, for each one, you don't need for numbers. Wherever there are numbers, you don't need them. But if it's string, it's best to use it.
Yeah, okay.
Yeah. So do that in your data frame. I think one is that is holiday X.
Okay.
So yes, from yeah, call that class from label encoder.
Can I, what do you say? Can I fold it like so that it doesn't appear big?
I think you can fold it. Just see if you can fold it. No, no, just double click.
Okay. Okay. Thank you. So X.
Yeah, so you have to call the class first. I don't think you have called the class.
LE is equal
No,
to.
no, you have to call the class. So first you have to import the class.
Okay.
So from
From
second
SQL
class,
and import preprocessing.
yes, yes, correct. Yeah, you should be able to autocomplete.
Okay. Okay. Then LE and so we'll be creating for holiday.
Correct. Yeah, I think it's a capital L. So yes, capital give capital L.
It gives it. So
Yeah, you did not execute that cell.
shift enter, right? It doesn't execute.
So if you execute a cell, how you understand is that the number comes up.
Okay, it's executed, right?
Yes.
Okay.
Also, let me tell you one thing. So, if you need to do fit and then transform, generally all scikit-learn have the method fit transform.
Okay, fit underscore transform.
Correct.
Okay.
So what it means is that it will fit and then it will transform.
Transform. Okay, and give a number.
Yes.
X dot X of is holiday underscore X.
Yeah, you this should also autocomplete. So can you this should also autocomplete. Generally it autocompletes.
Okay. Is that's it, right? I
Yes.
can.
So can you execute? Yes, it's coming, right? So what you do is that you directly assign it to the column. So in front of LE holiday, right? Yes. So X, yeah, X. This one is holiday. X is equals to yes. It should go in. And then probably you can do X dot head. So I did you execute for 18?
Yeah.
I
Oh,
don't think you have executed that.
I didn't execute this.
Yes.
Oh yeah, I didn't execute this after changing it.
Yeah. Now do it. Yes.
Yeah, got it. Yeah.
So you can see all the false became 0 and true 1.
Yeah.
Yeah. Okay, what else do we need? Uh, okay, there is
So
type.
for this,
The same thing on type as well.
same thing for type. Yeah.
Yeah, I don't think the spelling is correct. Also, you have not executed them.
Reprocessing dot. Which one? Oh, okay.
Yes.
Okay.
Yeah, so autocomplete should work.
Okay, then I'll have to execute both, I guess.
Yes. Oh, by the way, if you execute it once, that will again get executed. So it's better to execute that in a separate cell
Oh, they.
because X is already done.
Yeah. Yeah, it'll get executed again.
So that is why, yeah, move that to a new cell, the X type.
Okay, but it's okay, right? Like
Yeah,
it won't take long.
this one is fine.
Okay, but
Yeah.
yeah, anything which takes long, should put it in a different.
Also, if you execute the same shell twice, that will again get executed one more time. So it's better to not do the same thing two times.
Oh, okay, okay, okay. Hmm. And these ones as well, right? Like NAN
Yeah, this looks good. Yeah, your type looks good. Okay, what else? So
markdowns
yeah, markdowns are showing NaN. So if so, NaN
is
means
holiday.
not a number; they are null values. Oh, is holiday Y is also right. So you have to change is holiday Y as well.
Yeah, I'll have to do that for. Oh, what is holiday X and is holiday Y, right? Okay. Can I do it here, or do you want me to do it in a separate here?
Yeah, separate cell is better. Yes. So those are separate. Those are kept separate. So yeah.
Okay. Yeah,
Yeah. Yeah.
markdowns are the only ones left.
So markdowns are NaN. So NaN means like missing data.
Okay. What is
So
NAN?
first, NaN means not a number. So pandas shows missing data as NaN.
Okay.
So what is the strategy is that if let's first see if everything is NaN or like there are some data that is present
There is data present.
in the markdowns.
Yeah. Yeah, here.
Oh, okay, okay, okay. So now there are various strategies that you can use in such cases. Okay.
Hmm.
One strategy is that you take the mean of it, or you replace the NN with the mean, or means you cannot keep the NN. You have to do something about the NN.
We can put a 0 or
So yeah, sometimes people put zero, sometimes people put mean value, or sometimes people put the median value or something similar.
hmm. So this
So
basically it means the markdown is not there for that particular week.
yes, yes. So maybe, what do you think? What should we do?
So markdown is basically price reduction, right?
Yes. No, no.
Uh,
Markdown is not price reduction. Markdown is, oh, markdown. What is markdown? I'm not sure what is markdown. In general, what markdown means is that there is markup and markdown languages.
hmm.
But in this scenario, I'm not sure what is markdown. What do you think is markdown?
I think there is supermarket weekly sales, right? So
Okay.
these products they might have been as part of a promotion, they might have been marked down, as in the
Oh,
price is marked down.
uh-huh.
So there are like 1, 2, 3, 4, 5 markdowns, and in some
Okay.
weeks there are markdowns, and some weeks there are no markdowns.
Oh, okay. So
So
what do you think?
promotions basically, I think.
Yeah. So what we should do for the NN?
Difference between the original retail price and the actual selling price. McDonald's are calculated by separating the actual price. Yeah, it's a price reduction.
Okay. So, so there are different strategies that we can use for NN. We can give zero. We can give replace it with the mean value. We can replace it with the median value.
Hmm. I think in this case we can put a 0 because no markdown.
Okay. Okay. Then let me send you a code
Okay.
for replacing it with zero.
Okay. And for the week also, do we make it as like a time series kind of thing, or
Yeah, I did not get you. What did you see? What did?
yeah? For the week, this is a time series, right? We'll have to predict the time series.
Correct. Correct. Correct.
So do we have to put it like a?
So if you could find the week number after epoch, you understand what is epoch, right? So epoch is the start of time in computer language.
Okay.
Generally, it's 1st January 1970, I think.
Okay.
So everything is counted in terms of epoch. So you can say this is like it will be like, for example, how many weeks would have gone after 1970? Some thousand probably.
Okay. Yeah.
Yeah, so you can say that this is the week. So in this way, you are capturing this is the week after epoch. So you can say, so in that way, it will capture the time linearity of this date. Correct?
Okay. So we'll have to transform the week into epoch.
Probably. I'll let you know how to do that. First, let's finish the NN thing.
Okay. Okay.
Yeah. So I sent you a link, Stack Overflow link. Can you take a look?
Okay.
Yeah, so you can say that df.fill na with zero.
Okay. So df dot fill in with. Oh, okay. That's easy.
So in your case, instead of df, it will be
df underscore merge or x.
Yeah, X should be, but just go a little bit top. You have converted your, okay, Y is weekly sales and X is, okay, okay, fine. Yeah. So
Y
yeah,
is just one figure.
your DF is X, correct.
Yeah, we have to. This is the value that we need to get using regression.
Yeah, yeah,
Weekly sales. Everything else I put made it as x.
yeah, yeah, that's fine.
X dot lna.
No, no, you have to fill in. So DF is the whole, this one. So what you will do is that you will give the specific column.
Okay.
Yeah.
Column or columns, right?
So I think it's better to do it one by one. So you give
Okay, okay.
column. Yeah. Which column is it? Markdown something something.
Markdown one. Yeah.
Yeah. So after that you'll do dot. Yes. So so now it's just showing. It has not saved it.
Oh, sorry.
Yeah, it's just showing the output. It is not saved. If you check x dot had, the x dot had would not have changed.
Oh, it has not changed. Eh?
Yes. So you have to assign it.
Okay, but it looks like changed, right? No.
You can see, you can go shift enter and then go to the next cell and see if it has changed or not.
It looks like changed, Jirip.
Yeah, yeah, you can go and see. You can do x dot head and check.
Okay. So it's
Yeah,
still there. It's not assigned. Eh?
yes. So you have to assign it. So in the beginning, yes, you write x markdown equals to, yes, correct.
Yeah. Now
Yeah.
it's changed.
So you do the same thing. Yeah, don't write in the same cell because you have already changed markdown one.
Yeah.
Yeah. So here you can probably write markdown 2, markdown 3, markdown 4, markdown 5 together.
Okay.
Yeah, did you execute it? Okay,
Yeah.
okay. Yeah, so your markdown, all these things are done. So I,
Yeah.
what is left is the tail part, correct?
Oh, yeah. Date part. We'll have to arrange it into that epoch.
Yes, yes, yes. So let me see if I can find something. Just give me
Okay.
minutes.
Jaideep?
Yeah, tell me.
Yeah, I think see these sales, they are dependent on month as well, as in like if we give a epoch, I think it will be like a you need a one directional like week number 54, week number 100, week number 200, like that, right? It will be like that.
Yes.
But the month information, I think, will be gone, because the sales may be this. It may be similar for each month, like between 2017 March and 2018 March. There will be like a correlation. So I think we'll have to pull that feature out as well, the month feature.
Okay, okay. So you can do that. Right now, we are just focusing on how to do the feature engineering. Okay.
Okay, okay.
Yeah, if you think that is important and that will bring in more signal to our
Hmm.
X, then of course you can do that. Try that out.
Okay. So there is nothing called. I mean, is there something like 18 2010 is like 18th week of 2010, and then I mean, does it take into account that this is a week rather than just a number?
So how the means the general models work is that the general models generally do not care about how you are actually writing the numbers. It's kind of, so if your numbers are not random and they have a kind of how I can say, signal and information in them, the models will capture it.
Okay.
Okay,
So,
so if
so
you create your numbers in a specific way and they are predictable, your models also will become predictable. So
okay,
it does not really matter in which way you transform your uh, uh, possibly a date or string classes into corresponding numbers.
okay. So in
Yeah.
this case, 18th week, 18 2010 is it should be the sales in that week will be correlated to 18th 2011, 18 2012. So so it will capture that the correlation, right?
Okay, okay,
Since it is all 18th week, starts with 18 the number.
okay. So what you're saying, you just want to keep 18 instead of 18 2010?
No, no, 2010 will also be there. So I'm
Uh-huh.
just wondering if the algorithm takes into account weeks, or does it just ignore
So
and consider it as a number?
So the thing is that you cannot really say before you have actually run it. So how it
Oh,
generally happens is that you create a set of features, you test it out.
okay,
You create a second set of features and then you test it out again.
okay,
If you see that the second time the prediction capabilities and generalization capabilities are better, then you keep the second set of features and discard the first set of features.
okay.
If you see that your prediction capabilities have become worse, then you discard your second set of features. You're understanding the flow?
Yeah, yeah. So it's trial and error.
Correct. It's a trial and error method. You can't really say what is signal, what is noise, which features the model will be able to capture, which not. So those kinds of things kind of come with domain expertise and a lot of trial and error. So yeah, you cannot really say all those things beforehand. Possibly due to the fact that you are in retail, you will be able to uh, say better things about retail related stuff.
Okay,
Okay, so those kinds of things generally come with domain expertise.
okay. Hmm.
So yeah, let's do that. Let's just not transform it anymore, and let's just keep these set of features, and let's just see what is the capability of these set of features. Anyways, we have transformed everything into numbers, correct? So
Yeah, yeah.
yeah, this is essentially a matrix that we have already got.
Okay,
Okay, so let me see. So the second thing, so do shift enter. So our feature engineering is done. We'll transform our x and y into test and train. So
Okay.
why is that important is that you always train your model on a training set and then you test it. Okay,
Hmm.
you never create your model on the whole data set. Why this is so? Uh, because you don't want your model to overfit.
Okay.
Okay, so this is kind of important, but let me see if I have some kind of theory in it. Yeah, I have sent you a link. Can you open this link?
Yeah.
Yeah, can you go a bit below? I'll highly recommend you to read this whole thing, but can you go a bit below? Yeah, go a little bit top, go a little bit top, go a little bit top. Yeah, this one. Why bother creating a test prediction? So first and foremost, we create test partitions to provide us honest assessment of the performance of our predictive models. So if you train on on your whole data set, what it will do is that your model will fit into your whole data.
Yeah.
Yeah, but what is your goal? Your goal is not to fit. Your ultimate goal is not to fit your model into the data set, but your goal uh,
Predict.
is to create such a model that it does good prediction on unknown data, means future data or unknown data.
Yeah.
Yeah, so that is why you create a training and test. You split your data set into training and test so that after training you have a test data set so that you can test and see the generalization power of your model.
Hmm.
Does that make sense?
Yeah.
Okay, so because training is just training, but your ultimate goal is to create a model that generalizes effectively.
Yeah.
Okay, so let me send you the code how to split it.
Okay.
Yeah, I've sent you on Hangouts. Yeah, so go a little bit below. The code should be below. Yeah, so from scikit-learn.model selection import train test state xy. No, no. The next one, x train x test y train y test equals to train test split xy test size. So you define your test size and your random state.
Okay.
So test size you can give, generally people give 0.2, which means that take 20% of the current data set and make it test, or
Okay.
so 20 to 30 or 33% is fine. Random state you can give 42, that is fine.
Okay.
So yeah.
X train X test, Y train Y test is equal to train test split. Okay. Of X, comma Y, give the X and Y, and then test size and random state. Okay. Scale-on that model selection.
Yes, from scikit-learn model selection import train test.
X
Yeah, X train, Y train, X test, Y test.
test, Y train Y test.
Is this the correct one? Can you check once? X train, X
X
test,
train
Y
X test, Y train Y test
correct.
is equal to train test split.
So X.
Comma Y comma test size.
So your Y is capital Y?
Yeah, capital Y.
No,
Both
no.
are
Your Y is capital Y?
yeah, capital.
Okay, fine. Yeah.
Test size is equal to 0.2.
So 0.2 it means 20% you are defining as test size.
Okay. So when I press tab, it's not coming.
Oh, okay. So random underscore state, I think.
Okay, done.
Okay. So do shift
We
enter.
can we can check this one, right? Test size.
So yeah, you can. What you can do is that you can print the shapes. So can you print the shape of X? Just X.
X,
Yeah, just X.
explain.
So just X. X dot shape.
Okay.
So 42,000. So it's like 4,21,000.
Yeah, 4,21,000.
What is extreme? Extreme dot shape.
Extrain dot shape would be 20%.
No, no. Extreme
Right?
will be 80%.
X underscore. Okay. Oh, okay. Train is we're using 80%.
Yeah.
Oh, test size is just
Size is
so we
quite.
use more data to train.
Yes. So you give test size 20% to 30%. So train test split has two arguments. You can give test size as an argument and train size as an argument as well.
Oh, okay, okay. Yeah,
Okay.
80%.
Yeah. So give shift enter. Okay. Let's just do a basic linear regression.
Log reg, right? Log reg
No, no.
or linear. Linear
Logic
regression. Okay, okay.
linear regression.
So how do we we have to import something, right?
Yes.
Linear model.
Yeah, it should be in linear models.
Okay. Mhm. Linear regression. We have to get a class or something. Or
Yes, you should. There should be a linear regression class.
Okay, that's it.
Yes. So it should be like, yeah,
X train.
correct. X train, Y train. Okay. And let me send you this one. Okay.
Okay,
Yeah. So wait. Just give me 2 minutes. Let me send you some code.
okay.
Yeah, I sent you two links.
The first one or both?
You can open the first one also. First one is good. Take a look at the first one after this. Okay.
Okay.
Open the second one. Yeah, can you go a little bit below? So yes, in the code, go a little bit below. So you have completed till predict.
Uh,
So they are doing diabetes y predict equals to regression dot predict. So you have fitted it already.
okay. Now we have to
And
predict. Hmm.
yes, so you copy paste the remaining code, or if you copy paste and then you have to change the specific
Okay. I
stuff.
can
Yeah.
predict, right? Y.
Y underscore predict.
Oh, sorry. Y fetch. No.
No, no,
Y
don't.
train, right?
No, no, no. You do. This is predict. So
Okay.
yeah.
Prediction. Okay. Y underscore predict.
So what you are doing is that you have your Y test.
Sending the Y test, right? Sending the X test.
So
No, no, no. Okay.
you have your Y test.
Yeah. Okay.
Wait. Let me explain it to you. Don't type. So
Okay.
what I'm saying is you have your Y test.
Yeah.
So what you'll do is that you will find Y predict based using linear regression model on X test,
Okay. And then
and then you
compare.
compare. Correct.
Okay. Okay. So compare the prediction with the actual result
Correct. Exactly.
with X. Okay. So that's done. So difference between Y predict and Y test we'll have to do, right?
Yes. Now see, yes, see the code. You see they have done some plotting and everything.
Okay.
Yeah, just copy paste them and see. Try to make it work. So your print coefficients, regression. So your regression coefficient is L reg. Yes, L reg.
Interesting.
Yeah. Mean squared error is yes. Replace it with your test and replace the predict with your predict. Okay. Variance score yes. with your test and predict. So you can see explain variance code 1 is perfect prediction.
Sorry.
So it's saying that explained variance code 1 is perfect prediction. So if your
Okay, okay.
variance code is 1, that means it's perfect.
Perfect prediction. Okay.
So your PLT, those matplotlib stuff are not done, correct? So you have to call your matplotlib and create your PLT variable.
Oh, okay, okay. PLT. Okay.
Okay. Also, one other thing is that plt.scatter x test takes one column, but your is a matrix.
Yeah.
So probably it will not work. Let's not try to plot anything now. Just execute. Yeah, just comment it out. So if you do control forward space, it should comment it. So forward slash
Okay. Okay.
control. Yes, do control enter. Plt.show. Where is plt.show? Why is it giving like this? This is commented out, so why it is giving?
Yeah. It's commented, right?
Yes. Can you just delete them and yeah, just remove these and then print. Yes, yes. So you have not closed your bracket in print.
Oh, okay.
Yes, now good. Okay, mean square. Oh, you have to call your mean square error. Can you call your mean square error?
Uh,
Go to the code, and there will
yeah.
be no place. Go to the code, the link that I sent you. Yeah, see where they call the mean square error. Go a little bit up.
Oh, okay.
From
SK matrix.
yes, yes. From scikit-learn metrics, import mean squared error and R2 score. So is
SK learn. Okay.
sklearn. Yeah, both mean squared error and R2 score. Because you are using R2 square as well. Yes. Yes. So your variance score is 0.09, which is pretty low. It's, it's not 1.
It's very bad, right?
It's very bad. And also your mean squared error is very bad.
Okay.
In any case, this has been how you actually do it. So it's like a iterative approach. So now you know that your model is bad. So you think of ways in which you can, you know,
Oh, okay.
improve your model, and then you test it out, and then you see if your errors and
Mhm.
everything is getting better. Then you test it out again and such kind of things. You try out different models, and
Okay.
that's basically it.
If you want to execute everything below, how do we do it?
So you go to cell.
Run all below.
Yes.
Same thing. Even if I change the train size to very low, it's still
Yeah, you don't
forces.
change your training size to very low. Your training size should be around 70 to 80%,
Oh, okay.
because you want your model to learn, right? Your model will not learn if your training size is too low. Best case is, of course, if you it can get as much data as possible.
Hmm.
You want to keep some for the testing as well.
Yeah.
Yeah.
So variance, it still remains the same. Bad predictions, right?
Yes, bad predictions.
Okay.
So, okay, we'll keep it at 8. Okay.
Okay.
So tomorrow we'll probably not means, have any session. So on Saturday
Okay.
you are coming to the center, right?
Yeah, yeah.
So we can discuss we can discuss more strategies that can be employed there. And the next thing that I would like to cover is visualization.
Okay.
So visualization is very important.
Okay.
Okay. Okay. Thanks, man.
Okay. Yeah. Thank you. Good night.
Yeah. Yeah. Good night.